And as is our custom, welcome our green theme presenter, Karim Chatti from the Department of Civil and Environmental Engineering. And I understand that we're going to learn something tonight about different ways to pave, I don't know, roads, parking lots, driveways.
Pave the way.
Pave the way. Please pave the way. Welcome and thank you for coming, and can't wait to hear what you got to tell us.
Well, thanks very much for the invitation. I'm very happy to be here, especially that I'm a new resident of Meridian Township. I've been in Michigan for more than 35 years, but I've hopped around, and so I just moved this past month to Okemos, so I can contribute to the township that way. Yeah, I'm going to give a very brief overview of pavement preservation and really touch on potential impact on the environment. But I'm not an environmental engineer and I'm not a chemist, but at least touch on that.
Well, I believe our hydrologist is watching from home. She sends her regrets.
Susan?
Susan Maston
decided
to...
she's the connection there.
Yeah,
so.
to avoid infecting the rest of us with whatever has got her down. So
I'm glad
I'm
she
watching
is.
closely for her questions from home. So you're on television. Be careful.
Okay, so I'll give a brief background, some definitions of preservation, the philosophy behind preservation, a few examples of some treatments, preservation treatments, the importance of predicting the life of the treatment and the costs associated with it, the importance of the principle of optimal treatment selection and timing. And then I'll introduce you to a new tool that we've been working on with the University of Illinois as part of the center that we have at Michigan State that is for life cycle assessment, specifically for pavement preservation treatments. So we all know that the U.S. infrastructure has been getting these poor grades. So ASE year after year has been giving us a D plus or D. And of course that's not good. A lot of money is needed to restore the whole network into an acceptable condition. More than or about 2/3 of the roads are in less than good condition. And we all know that the federal taxes or the funding from the federal tax has been decreasing over the years. They've been reluctant to increase that revenue. And so everybody's under stress to keep the system at a decent condition. Of course, transportation and the environment are not foreign to each other. Transportation contributes to about 30% of the greenhouse emissions. So obviously that's an important topic. It goes globally. Nobody, I think, questions the fact that the globe is heating up. The seas are rising and all of that. So it's particularly important to talk about the environment in any context, and in this case, I guess the small role that preservation can do to help. I want to put a plug for the National Center of Pavement Preservation. Its director is Judy Corley-Lay. She was a long-term pavement management of North Carolina DOT. She succeeded to the founding director, Larry Galehouse, whom you may have interacted with. And that's really the outreach. That's a national center. It's an outreach, the outreach arm, I call it, of the state highway agencies and the Federal Highway Administration. It has a lot of programs that are funded by a pool of state highway agencies, FHWA, industry, and so on. It has an educational component. It does a little bit of research, but mostly help researchers implement or technology transfer all the products that are being developed and promote, of course, preservation. So I think that would be a good source for information and perhaps cooperation and so on for the township. Okay, so the definition of preservation is really, we need to look at it globally as a system or as a long-term strategy for a network to extend the life of the network as a whole. If you want to go to the specific project level, then we're talking about a preventive maintenance, which means that if we do minor treatments to a pavement in good condition, then we're going to extend that life of the pavement for a few years. We keep doing that, or several years, and we keep doing that, and then we benefit overall as opposed to waiting until it's too late. And the cost is high, both economically as well as environmentally that way. And so if you look at the cycle, the life cycle of a road, you start from design, obviously construction, then you have in the first few years the initial deteriorations, which may not be visible, to the eye. And then you get to visible deterioration at the surface, and then obviously what we want to avoid is complete disintegration and failure. So the idea is very simple, really, is to, oops, I thought I had a different slide. Let me go. Maybe not. Like this. Well, anyway, the idea is to act during that initial deterioration, during the first few years, not to wait until visible deterioration and so on. That's the idea. Of course, 90% or more of our roadways are asphalt surfaced. And so a key component of preservation is really stopping the aging of the binder or the chemical reaction of oxidation. Because it will, of course, oxidation will harden that binder, which means that it will lead to a loss of the bond between the stone or the aggregate and the binder. That leads to raveling, cracking, etc. So basically, if we protect the surface from the air, from oxygen as much as we can, then it should live longer. In a nutshell, this graph kind of explains the philosophy of pavement preservation. So if we plot pavement condition on the y-axis and time on the x-axis, now obviously we start with a brand new pavement, which has the best condition. And then with time, if we don't do anything, then of course the pavement will deteriorate. So traditionally, over the years, we've been waiting too long, and then we would spend quite a bit of money to rehabilitate the pavement. And of course, the longer we wait, the more costly it is. So preservation, which really started being pushed in the very early 90s. And Michigan DOT, by the way, despite the road conditions in Michigan, was one of the lead states or state DOTs that pushed for preservation. And Larry Gehrhaus, the former director and founding director of the National Center for Pavement Preservation, was a key champion of that. So the idea is that if we act early enough, as you see in the green, you see in the green curve at the top, then we spend a little bit, and we extend the life of the pavement by, let's say, 3 to 5, maybe 7 years. And we keep doing multiple cycles to keep that condition high. All right, some example of the cost, just to get an idea. So if you go with there are many indices to describe, let's say, the pavement condition. One of them, very common one, although Michigan DOT uses a different kind of index, but nationally is what's called the pavement condition index. So think of it as 100 is perfect, and then of course going down, you get a poorer condition. So if you spend early, when it's in very good condition, you may spend, let's say, $10,000. And then as you go down in that condition, then you could double it if you go, say, to the third category, or you could quadruple it if you go all the way to the 60s. So it makes sense from an economic point of view. And the claim from the preservation industry and the preservation community is that every dollar you spend in keeping a good road in good condition precludes you from spending as much as $6 to maybe even as high as $14 if you go all the way to full heavy-duty rehabilitation. So it makes perfect sense from an economic sense, from an economics point of view. Of course, the problem is the budget constraints and looking at the whole network. So it's not easy to implement. It takes a long-term strategy to get there. All right, very brief overview of typical or common preservation treatments. I'm going to focus on the asphalt pavements because that's the overwhelming majority, but there are also a few options for concrete pavements. So for asphalt pavements, you have all sorts of seals which give you increasing levels of life extension and protection. They're all non-structural. They don't add any structural capacity to the pavement. The heaviest of which would be the thin, what we call the thin HMA overlay. We're talking about less than an inch type of an overlay. So this would be a non-structural overlay. There are other technologies like microsurfacing, which is basically the kind of the next generation of the traditional chip seal. Then people more and more added the heavier sort of, so to speak, actions such as recycling. So hot in place recycling, cold in place recycling. They are part of the preservation toolbox, but some people may argue that you're getting into rehabilitation. So sometimes you don't have a choice but to do that though. Okay, I'll skip over the concrete pavements if you don't mind. And here are some examples of those seals. So you can start with a fog seal, which is really just a protective binder that's gonna protect the surface, let's say what we call a dry surface, from the air. And so it's a sealant of the entire surface. Okay? Obviously, you can't expect many years out of it, but it will give you a couple of years, a few years, extending that life. The best example I give to, non-technical folks is that if you have a driveway which doesn't receive much traffic, right, just our cars and so on, so structure is not the issue as far as the loading, or the loading is not the issue, I should say. If you don't seal that driveway every once in a while, then it will deteriorate with time, without any, because it doesn't get much traffic. So you could see one neighbor that's been pretty disciplined in sealing that driveway versus another who hasn't, and the deterioration can be quite significantly different. So that's exactly what's happening in roadways if you don't do that. Of course, these are the least expensive, but they will have the least amount of life extension. And the public likes them because they make things look nicer and they don't disturb the public. And they are very fast to, you can do it very quickly. Then you have the heavier duty slurries, different types of slurry seals. And these can be effective in moderately distressed roadways. It will provide good skid resistance. They are non-structural still, but they can be applied to a heavier load and heavier traffic volume with higher speeds. Then you go to the traditional chip seal, this the oldest technology really. It's non-structural. You can have single layer, or 2, 3 layer, etc. The public is not a big fan of these because of the chips or the stones flying out, the potential for those. But it's really a good, durable solution. It's a reasonable price, and it gives you very good skid resistance. So that's the traditional non-structural seal. Then you have newer technologies such as the microsurfacing that the public does like because there are no stones that fly away. It's of course costlier, and it has a good performance in terms of extending, so it has a good durability, and it has a good skid resistance, a good life extension as well. By the way, it's very good in filling the rut depths at the surface. And like I said, moving sort of into, you might call it minor rehabilitation, we can talk about milling and recycling, and this could be hot in place recycling where you could recycle within, at that top layer, or you can do cold recycling, and that would have to be at the deeper layers, and then you add a thin overlay on top of that. Here's an example of comparison of strategies that I borrowed from Cal Poly Pavement Recycling and Reclaiming Center. It gives you at the top the surface seals, Obviously, you apply those to pavements that are in very good condition. They are the least expensive, but they will give you the least amount of life extension. They even provide some green rating for those for the different types of strategies. And then as you get into poorer conditions, then you get into thin overlay, hot-in-place recycling, hot-in-place recycling plus seal, etc. And at the very end, or the heaviest, would be milling and then thin overlay. Oh, sorry. So you could see that the range of lives is maybe 3 to 7 years, I would say. Some people claim you can go into 10 years, but that's with a thin overlay. This is a busy table, but it's just to give you to give you the information that people have been tracking the lives of these different treatments, and of course tracking the costs of these treatments. Some of them get into the more of a rehabilitation type whenever you deal with overlays, and then you see claims of 15 or more years, and I'm not sure about that, but that's the literature. We've also done a survey of state highway agencies nationwide, and to look at what are the most popular treatments. And not surprisingly, the most popular for flexible pavements is the chip seal, and followed by the thin overlays. And then microsurfacing is a distant third, and most likely because of cost and because of the differences in technologies out there. For rigid pavements, most popular by far is the diamond grinding and joint sealing. Get rid of the roughness, basically, of the concrete pavement. And in some cases, of course, you need to do some partial depth repair. A key to maximizing pavement life is really, and this is kind of a slogan, applying the right treatment on the right surface at the right time. And it's easy to say, obviously much harder to implement, right? The devil is in the details. But what do we mean by the right treatment? Well, if we have a better scientific understanding of the behavior of the treatment and the mechanical characteristics and the properties of the treatment, then we have the right treatment. In other words, we can choose the right treatment. And if we have the right diagnosis of the condition of the existing pavement, then, for example, through non-destructive testing and so on, then we'll have the right diagnosis. And then if we have the right deterioration models, and these could be ideally some kind of a mechanistic empirical model, but most of the time it's too complicated of a phenomenon, so it's mostly empirical. But nonetheless, if we have some deterioration model with time, then that will help us in selecting the right time. All right, this is a very busy slide, so I don't intend to go over it, or I don't expect you to read it. Just to say that there are tools out there. People have been developing tools, what we call decision trees, which help the engineer decide on the type of treatment depending on the condition, depending on the traffic level, environment, et cetera, et cetera. So there are these tools out there available. And finally, I wanted to I'm proud of this, that part of the center, we've been working with the University of Illinois as the lead. The center is based at Michigan State, so Michigan State is the lead, but we have many projects. One of them is to develop this new life cycle assessment tool specifically for pavement preservation. And it's intended, of course, to be used by state DOTs, cities, counties, townships, etc. And this tool is essentially done, but it's not public yet. And it allows the user to put all the, of course, project information. It gives you different alternatives to choose from. It has its own database so that it can provide you with models for that deterioration models, and its own database for the pay items and so on. Then it goes through the detailed calculations of the life cycle assessment, different phases, from materials construction, the use phase, and it even includes a work zone module, to take care of the costs due to congestion and so on. And then as the final result, it will give you the environmental impact as well as the cost or the equivalent costs. For those who are not familiar with the life cycle assessment stages, it's basically 5 stages, starting from the materials and construction, going on to maintenance and the use phases. And these are the 2 basically new things in this LCA tool. And then at the end is of course the end of life, and all of these can be quantified in an LCA strategy. Just giving you screenshots of the different screens that the tool has. So obviously you get the project information, you enter it. It has different options for pavement preservation and maintenance schedules, different treatments to select from. So it gives you options for you. For those who don't have enough information, it guides you. For those who have more information, they have their own philosophies and so on, then they select their own strategy. So it gives you both options. And then it has its whole large database of all the different pay items for going from material construction all the way. It has, of course, the use phase, where it has its own deterioration models, allows you to put your own deterioration model. For example, that this the screen in the middle there, that's just a simple linear deterioration progression curve for the roughness of the pavement. As I mentioned, it has a work zone module as well, take care of congestion, costs due to congestion from work zones. And finally, it gives outputs, a very simple kind of outputs in terms of costs, depending on for the different strategies, as well as the global warming potential in terms of CO2 emissions and so on. Of course, that tool is based on assumptions, based on particular databases, based on particular models, and that with the years, as we know more, then those models can be updated and so on. But I just wanted to let you know that such tools are being developed, and that and the environment is being taken into account more and more seriously, even by the road industry and so on. So thank you very much. I hope I didn't take too much time. Did okay, hopefully. And I'd be happy to answer any questions if I can, obviously.
Anybody up here? Yeah, I know yours. Ed, go.
So when you referred to the concrete, although you didn't talk
I
about it a
didn't
lot,
elaborate,
it
yes.
showed the diamond grinding and so forth. So that obviously raises the question of how deep should the original build be of any particular, whether it's concrete or asphalt. How much can we sort of resurface a road simply by taking off the top layer that's degraded and leaving the next layer? And along with that issue, the depth of material, also at what point do you essentially give up on any kind of preservation, sort of what depth of potholes, because of course that's a major issue at this point.
Right.
And I've never seen a patch material that matches the actual original material, so that you always end up with potholes reoccurring or becoming a lump or whatever it is, being still a perturbation to the smoothness of the road.
Right.
So how do these preservation strategies address those issues?
They don't address potholes, because once you have potholes, then we are outside of the philosophy of preservation.
Right.
So we're talking about then local maintenance that must do, such as the winter filling of holes that we see all over the place. We are way beyond preservation at that point. So the preservation is to act early. Mm-hmm. So that becomes just routine maintenance, reactive maintenance, and temporary fix till warmer temperatures, so that we can take care of it. So yeah, preservation is, you're talking about acting way earlier than getting into potholes and so on. In terms of depth and grinding, I wanted to make sure I don't miscommunicate. So grinding for concrete pavement is not about the deterioration of the concrete slab. It's about, concrete slabs or concrete pavements by definition have to have these transverse joints. And because concrete shrinks and cracks, so to control the cracking, we put these transverse joints. And so if that transverse joint is not properly functioning, then it will start faulting. And roughness is obviously a nuisance and can be a safety hazard and all of that. Causes fuel consumption increase, causes repair and maintenance increases for vehicles and so on. So grinding is just to level that slab that is just at maybe, let's say, maximum of a ½ inch, hopefully not more than that, because that's a high fault, and then grind it so that there is no more faulting. Now,
Smooth it, yeah.
grinding can be done in the wrong way if the source of that faulting is at the foundation of the slab. And you can keep grinding, and there is a void basically, and so there will always be pumping and faulting and so on. As far as asphalt concrete, I think you were alluding to eating up essentially that top layer or portion of the top layer, right? The milling part. Then how deep do you go? Well, you go as deep as the deterioration is concerned. Mm-hmm. So if the cracks are going to, more than a couple of inches, you have to go deeper than that. Now, if it has deteriorated to a certain extent, and then that's why I said people have they've been bringing it as part of preservation, but we're getting into now rehabilitation, really, for many reasons, okay? Mostly political, so that the funding goes to the preservation kind of theme, mostly. But recycling an existing pavement is a good solution. It's a good solution. Of course, the key is in the devil is in the details always. And so you need to rejuvenate the existing binder. And if you have the proper rejuvenation, if you have the proper binder content and so on, then you can have a decent product. And there are thresholds, limits on how much old material can you use within that newer material and so on and so forth. I don't know if I've answered your question, but
Well, an element of the question was, in a sense, what choices, or how did these guide the choices essentially of depth in the original construction? If you want to sort of give yourself room to mill it down, to essentially to leave a new surface, or at least to have a reasonable share of still stable surface underneath that will support the rejuvenated surface. I guess the question was,
okay,
how deep
right,
does that influence the
there is
original
no limit
construction?
really yes, so there is no limit as far
plans.
as how deep, because it just depends on what, in other words, if you are recycling a material, and if you've and now we are really past the preservation, we are beyond that, that criterion. So if you go deep, then you are really into rehabilitation. Okay. So it's outside, but still, I will try to answer that. So if you are at that stage where you really have to recycle the entire, let's say, layer, okay, asphalt concrete layer, then you are into rehabilitation, and that recycled layer cannot give you the same structural capacity of a brand new layer. Okay. So therefore, you need a structural overlay, maybe not too thick of an overlay, because that becomes a base, a good base, that recycled material. But we're into now really rehabilitation, but there is no limit as far as how deep you go, though, as far as recycling. You can go as deep as all the way to cold recycling to the base. And it's definitely then rehabilitation, but it's a good solution.
Okay, thank you.
I'm not sure that I can even phrase a good question here, but
I'm sure you can.
I've driven enough of Michigan interstates with concrete that you thump, 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 and all that.
Right.
And when I visited with a friend in Germany, on one of the Autobahns, it seems like they can get up, I don't know what speed, but it's got to be closer to 100 than whatever.
Yes.
And you're just driving so smooth, you just can't, you don't hear or feel anything.
Yes.
And I wonder, are different weather, are different climates, or is their engineering
Well,
better than ours? Or
very good question.
How,
So-
how,
Yeah, very good question. So first, the Germans, they are among the best in concrete pavement technology. So that's a fact. And you probably know that the interstate concept or the interstate idea in the US was borrowed from the Germans,
the Autobahn.
right? The Autobahn. And so the Germans are really good, technically. It doesn't mean that in the US we don't have the technology or we don't have the knowledge. It's more of a philosophy of how do we build and maintain and manage our infrastructure. In the US, for political and economic reasons, we allow for the low bidding and we allow for smaller projects, smaller contractors, although that's changing. And there is a plus to that from an economic and socioeconomic point of view. In Europe, they have a different philosophy. And and the US is made up of 50 plus states and all of that. So it's much more complicated, right? And than in Europe. In Europe in general, and Germany would be an excellent example, it's certainly for concrete pavements. They go for the long life pavements. And they have a different philosophy. So they put the high dollars at first, and they have essentially these huge contractors that are essentially monopolies. So you'd have a few who basically give you a design, build, warrant project. So it's really a philosophical / political decision as opposed to, or situation, as opposed to a technical issue, although the Germans are particularly good in the concrete pavement industry and in many industries, as you know. So I'm not sure if I answered, but that's the background behind it.
Thank you.
I've heard that issue about warranties before, and that seems like one worth hearing more about. But Susan is watching and following closely. Had a couple of questions she'd like me to pose to you. And I think you alluded to some of this a little bit, the first one earlier, about the connection, the relationship between the quality of the pavement and gas mileage and air pollution. Is there a
Sure.
rule of thumb for the impact of the poor road condition
Yes.
on gas mileage?
It's more than a rule of thumb, because I happen to have led the project, the national project, funded by the National Cooperative Highway Research Program, which is part of the National Academies, that with the objective of coming up with models for estimating user costs due to the road deterioration. So as part of that, and that's those models right now, people are using them not just in the US but in other countries as well, in LCA calculations and so on. So we've shown through careful experiments as well as through mechanistic models that these effects are small, but when you add them, when you add the huge number for traffic volume and so on, then they get into the many billions. And so we have a model that predicts the excess fuel consumption depending on the vehicle type as a function of roughness. Roughness is the biggest culprit. And that we've shown that statistically and mechanistically. So that's a fact. And then you have the effect of texture, although the effect of texture is secondary. And then, and this is politically kind of charged, and it wasn't actually published as part of that report at all because we were told we don't want to get into that. But then there is the structural rolling resistance of the pavement itself. And so the asphalt and concrete industry, the concrete industry claimed that the asphalt pavements will cause higher deflections, therefore higher rolling resistance and so on. We looked at that. We didn't publish it as part of the NCHRP report, but we published a few papers. And the bottom line answer to that is that in general, for cars, there's no difference. For heavy trucks, If it's at low speed and if it's summertime condition, then you can see that difference between concrete and asphalt. And of course, for thicker asphalt pavements, then they are equivalent to the concrete pavement. So yes, I mean the surface condition, roughness is the biggest culprit. Secondary order, you have texture, and then really a minor factor would be the pavement structure itself.
Thank you. The second question had to do with, we're blessed with a lot of wetlands in this part of the world.
A lot of?
Wetlands.
Okay.
And wondering about the connection between our bounty of wetlands and the quality of our roads, and are there things that can be done?
Mm-hmm.
We're partially, as a commission, in the business of preserving wetlands.
Sure.
And encouraging their creation whenever they're disturbed.
Mm-hmm.
Are there considerations with regard to road and road longevity that we should be aware of?
Well, in general, of course, water is an enemy of any civil infrastructure. So that's a fact. But for roads, basically, one has to make sure that drainage is adequate. So I don't see, kind of a fight between wetlands versus roads, as far, being a road person. As long as the roads are properly drained, wetlands should not be an issue. Now, if you bring up wetlands and, let's say, high water table in general. So high water table, and it has, it's not particularly wetlands, but high water table in general is something that road engineers have to take into consideration very carefully. So because of course, in a freeze-thaw environment and so on, the higher that water table, the more trouble we're going to have. Unfortunately, because of budget issues, right, we don't have thick enough pavements and thick enough subbases, permeable subbases. So from a technical point of view, we know that the thinner roads that are not protected against frost depth, they're going to suffer. And that's why in the interstates you don't see damage due to frost depth. I mean, that would be a disaster if we see that in interstates. So, it all comes down again to money and where do you want to put your money.
In particular, one of the things that we've talked about recently is trying to get pretreatment on stormwater coming off of impervious surfaces. So the notion of moving away from curb and gutter with storm drains to ditches and bioswales and such. Does that have any influence on road design? Should any special consideration be taken in those cases?
Well, I don't know that I can answer you in any specificity, because basically, as far as road design is concerned, we want to, in other words, I don't have the numbers or the models to answer the question, but as a concept or in principle, the whole thing about drainage for roads is to make sure that the road is not saturated, that the water just goes, that flows away from the engineered structure. That's all. You can have water as much as you want, as long as it flows and it doesn't stay there. Doesn't because we've shown it that it's a function of the degree of saturation. So if the degree of saturation reaches a certain level, the performance, starts here and then just abruptly, essentially gets killed. So as long as you can minimize that duration for the saturation, which means proper drainage, then you're fine. So when you change the drainage system, then it's a matter, then you need a model really to predict, and that's a hydrologist's question, to predict the flow from a different geometry, from a different, configuration.
Yeah. I think a lot of times when we think about pretreatment, we're wanting to delay the draining of that water to get the sediment to settle and to keep the water nearby. But what you're saying is get it off of the engineered surface first before you let it sit.
Yes, absolutely. Because you can kill a pavement, brand new pavement, in no time if you let it saturate.
Mm-hmm. Anybody else?
So one more question about the materials. So, for example, the
fog seal, yeah.
Oh, sorry. With the fog seal or things like that. The other aspect of runoff, of course, is what sorts of substances end up with these resurfacing
Sure. Yeah.
in the runoff water. Is that a big concern or not? So is the material, like for example, the fog seal, is that more or less the same heavy oil that's the binder in ordinary asphalt, or is it a different?
Well, it depends on the source, yes. So if it's asphalt is a hydrocarbon, right? If you compare asphalt to, petroleum-based asphalt to tar, then of course you have different chemistry.
Right.
And in general, for sure, asphalt would be more benign than tar. Yeah.
But what is typically used in, for example, the chip seal process and the fog?
More and more states are using certainly petroleum-based and emulsions. In the old days, they used to use solvents that are not water-based, and those are gone. Those days are gone. So in addition to the binder, the core, the binder.
I see.
So they used to have
mobilize.
they used to have petroleum-based solvents that are even worse in terms of fumes and all of that. So now it's water-based emulsions, and if you have water-based, obviously water is perfectly fine, and then if it's asphalt, petroleum-based asphalt, then it's the least damage that you can cause. They have other products. I'm not a material scientist or a chemist, but they do have other products out there. They tend to be like maybe 4 times more expensive or more.
Of course, right. But that was the last question I was going to ask.
And the durability
what are the
of those products, because they're not used nearly as extensively, so we don't have the data on those. At least I'm not familiar with any serious study that looked at the durability of the non-petroleum-based binders.
Yeah, that's what I was just wondering, if there were emerging technologies, really new strategies for limiting oxidation, especially of asphalt surfaces. That seems like, that is a chemistry question at some
It's a
level.
chemistry question, and I am not the right person to answer that from a chemistry point of view, certainly. But, to add durability to any binder,
Well, he already mentioned.
then adding polymers certainly will add the durability and so on. Yeah, absolutely. And it will help with the curing if you're doing an emulsion as well.
So has
that
anybody?
costs a little more, of course,
But has anybody, therefore, actually found a way to, for example, use recycled plastic? Those are polymers too, and if you
Right.
treat them right, you can actually probably dissolve them in asphalt.
Yes, so people have been doing those kinds of things, and the most common thing is the rubber
Right.
based recycling.
Tire crumbs.
Yeah, and the technology, Michigan DOT, for example, hasn't been, I guess, forthcoming as far as using, the crumb rubber because of horrible past experiences, back in the 80s or whenever they started, I think even the 70s. But the technology has changed significantly. And so for Michigan, I have a colleague of mine who's been doing this through funding of the environmental DEQ. And they've been doing, probably in Meridian Township, Ingham County, so including Meridian Township, they've been trying all sorts of different crumb rubber technologies on like Hazlitt Road and several roads like that. So as far as, so it's been happening, and maybe you want to invite him to talk about that aspect, because he's been working on it for now more than 10 years, I think. Yeah, more than about 10 years, with funding, like I said, from DEQ and Ingham County as a partner, as a cost share. So
Very interesting. Thank you.
Yeah.
Go ahead.
From the life cycle analysis comparison, is there like if you're looking at the embodied energy, the potential harmful chemicals, the global warming impact, is there a comparison between cement and asphalt? Which one comes out ahead?
well,
I'm sorry, could you repeat the question for the
Okay, so the
recording?
question is, from a life cycle assessment essentially point of view, is there a clear difference between asphalt and concrete pavements? And because the environmental concerns are more and more there, obviously nobody's ignoring that. So people are trying to improve both industries, but it's still there is no definite answer. So both industries are looking at that question, and it's that important for the concrete industry when it comes to roads. Concrete industry is kind of the minor player for obvious reasons. 90% of the roads are asphalt. So they've funded a whole center at MIT called the Hub Center, a multi-million-dollar center with people who are authorities in material science and so on, trying to, objectively, because obviously they want to tie to a university, show that concrete is a more sustainable solution that way. But there is no, there is no definite answer right now. Yeah. And that's why these LCA tools are coming up, and more and more jurisdictions are, we're not there yet, but we're almost there. California is definitely ahead of everybody else there, and they are requiring each of those industries to provide essentially the data sheets to support the numbers that they're coming up with and all of that. So that's ongoing. Yeah.
And one more.
You had a chart that included green, and what did you include? What were you were comparing the different
Right.
preservation strategies,
Right.
and you had
Right.
two of them that had a plus for green.
Right. So,
So what did you mean by that?
right. It's not my chart. I just gave it as an overview. I put the source. It was Cal Poly Recycling Center. And I don't know the answer to that because it's kind of tied to your question. It's a very fuzzy thing. That's why we're putting all sorts, everybody's putting all sorts of effort to try to bring it to a scientific level where everybody agrees on what it means to have this equivalent cost and all of that. We're in the middle of that struggle right now. So what criteria they've used, of course rational criteria, but then to change from one degree to another, it's it's a different ball game. So it's a very, very sensitive, of course, very sensitive question.
I was wondering what, if you know, like what the frequency is of like preservation techniques being implemented versus the frequency of road recycling.
Oh, sure, a proportion perhaps you meant, right?
Yeah.
So it's
Could
it's
you
less
repeat
than-
that question?
Yeah, so the question, I think I understood it as proportion in terms of preservation versus recycling or heavy rehabilitation, which can mean frequency. You put it
It
in.
just seems like there's a lot more like road recycling happening.
Absolutely, absolutely, yeah, absolutely. So it's less than 10%, and I'm being very optimist. And the problem is nationally. The problem is complicated because we already have, a $3 trillion plus investment. It's been there for many, many years. So we have if you look at it, whether it's a city or county or a state or nationally, you have on your plate, this is what we have right now. Since preservation was not a priority for many, many, many years, we're not at that, we are forced to deal with major rehabilitation, reconstruction, and all of that. That's why you're seeing. So, see, the whole idea of preservation is that if we started today and everything is new, then you can use preservation very easily because it's a matter of, you have this much funding or this many chips, and you have a whole network, and you're monitoring that network very carefully. And so you can put a little bit of dollars to make sure to maintain all of these. Some will perform better than others, and so you act on the ones who are starting to deteriorate, but early, and so you can get a lot out of your money. But the reality is that, you know, in the 1990s when this was talked about, I mean, people are still pushing for preservation now because it's the right thing to do, but the system is where it is. So, you know, you have a DOT or a township or a city and so on. They have a limited budget, and here's the deal. No, the state of affairs are not good, so they have to fix the worst condition first. But you can still have a long-term strategy where you would have to, of course, fix the roads that have, you know, pretty much disintegrated, obviously, but then keep a small portion of your budget and keep increasing that portion. But start with a small portion to still act on the pavements that are in good conditions, and little by little, you know, you're going to have a bar chart that's going to do this. But it's long-term. That's why in the definition, it says long-term strategy. A very good question, though.
Great. Well, if there's no more questions, well, thank you once again for coming.
Thank
Very
you.
informative. Appreciate it.
Thank you.